Unity just released a 119-page ebook on 2D game art, animation, and lighting. I decided to make a video walkthrough of the ebook and break it down into 4 core parts. This video is going to be great for beginners or intermediate, anyone even if you're just brand new to Unity. I've included the steps to get you started and set up, and you can walk through the guide as well. So thanks for watching. I hope you enjoy. Okay, so for part 1 of this 4-part series, what we're going to be doing is diving into this new ebook that just came out from Unity, and it's broken into several parts. There's really a starter section, which is a lot of theory, an introduction, and then there's 4 major parts after that: 2D animation, 2D lights, advanced visual effects, and post-processing. So today what I'm going to be going over for this video is the 2D animation piece. So to get you there, let's go ahead and do some setup. So we're going to go to the Unity blog first. Right now, if you go today or sometime soon, you can find it on the top right side of the page. We can open that up, and from here you just scroll down. There's all sorts of good resources here about 2D development. So if you click into this one, you'll find right here you can download the ebook. The next part, if you want to follow along with this and do these steps that I'm going to be showing along with me, then I recommend that you actually grab the Dragon Crashers 2D game sample from the asset store. So that is also available. You can navigate to that from the Unity blog. I'll click into that here, and from the blog post you can scroll down a little bit. You can find some good video content, and there should be, here we go, a link to the asset store. So once you're in the asset store, hopefully you have a username. If not, create a free user ID, and you can download this project asset package. Okay, so now that I've shown you where to navigate and find the assets, I'm also going to go ahead and start from scratch and create the Unity project. This is for beginners or anyone who's maybe even intermediate that still wants the walkthrough of the proper setup to do this. So we're going to go to our, first of all, our installs, and here is where you want to make sure you have the proper Unity LTS installed for this ebook that has been released. Now in the ebook, they do the instructions from 2020 LTS. You can use 2021 LTS, which there'll be some conveniences with that. There's updates that make some of the workflows improved and better. I'm going to be doing it from 2020 just because that's the way they wrote the ebook, and I want to follow the steps as the way they designed it. So I've got that installed. If you don't have that installed, just click on the install editor and find your release 2020, install the LTS. Okay, and once you have that set up, you can create your project. For the purpose of this video demo, I'm going to be following along with the ebook, and so therefore using the 2D core pipeline. We could be using, since this is an updated Unity hub, and we have newer versions of Unity, we could be using the 2D URP, which would include a lot of the packages that are going to be installed. But just to follow along, just show some of the workflows and how to get this set up traditionally if you're still on a 2020 LTS, I'm going to go ahead and do it that way. So I've switched my editor version to 2020. I'm going to, you see I no longer have the 2D URP available to me because I did that. And so I'm going to select 2D core. And now all I have to do is name my project and assign a directory location to save it to. So we'll call this 2D ebook part 1, and we will create the project. Okay, now that we have our project open and ready to go, we're going to do a little bit more of project setup. So if we were not going to use the Dragon Crashers asset, which we are going to, but for those of anyone that's just going to be starting from a very blank canvas, these next few steps are going to be important to you. So first, what we want to do is choose our 2D packages from the package manager. We'll get to the package manager from Window, Package Manager. And here right away we have everything that is already installed with this project by simply creating the 2D or selecting the 2D core from the Unity Hub. You'll see that by creating the 2D project template, the project has already installed for us 2D animation, Pixel Perfect, the PSD importer, which is really convenient, and we'll go over that a little bit, for when you're creating sprites, your characters for your project out of Adobe products, the 2D sprite package, sprite shape, tile map, and so on and so forth. But what we don't have here is the Universal Render Pipeline, URP. So what we're going to want to do is switch from the packages in this project to the available packages in Unity Registry and search for that. And here we are, we have it, so I'll go ahead and click install. Next, what we want to do is create a URP asset. So to use URP, we're going to create a URP asset and assign the asset in graphics settings. You can either right click in here in the project window, or you can go into the toolbar and find assets, create, rendering, and then universal pipeline, and then pipeline asset forward renderer. A renderer asset is created at the same time as a URP asset, and you'll need to replace this with the 2D renderer asset. To replace it, right click in the project window, or again go to the assets, create, rendering, universal render pipeline, and 2D renderer. Now we're going to assign the 2D renderer. So we're going to click on the universal render pipeline asset, and here in the inspector you'll see that we have the universal render pipeline asset renderer here loaded, and what we want to do is take our 2D renderer data and assign it to that. So we're going to drag that right in. And when you're done, it should look like this. You'll know you have it right because in parentheses it'll now say renderer 2D data. Now that you have the URP and 2D renderer assets lined up, assign the 2D renderer to the scriptable render pipeline settings in the project. Open the project settings window, which this can be found in Edit, Project Settings. And from here you want to go to the graphics section and assign the pipeline asset here. So we'll see that we have no pipeline asset. We want to click this button here and we will find our URP asset option. The 2D renderer is now set up and ready to go. You can also adjust the rendering settings by switching to the quality category in project settings, and there's more documentation about that in the ebook. Now, just one last thing, all those steps that we just did could be completely bypassed and skipped if from the Unity Hub you were to have selected a 2D URP project. Again, this is not possible if you're still on 2020 LTS, so that is the reason why we went through these steps. All right, now before we dive into 2D animation, I'm going to be working with the Dragon Crashers package to import in this project. So I'll show you how to set that up, and I encourage you, if you want to follow along, to absolutely go get this free project. It's got tons of good stuff in there, and to follow along with this video, it's only going to help you even more. So we'll go back into our window, package manager, and from here what we want to do is look at my assets. So with the link I showed earlier, hopefully you downloaded the Dragon Crashers free asset from the store. If you have, it should show up just right here for you. Now, with the package selected, what you need to do is come down and select Import. So you may get a warning just like I did if you have followed the workflow so far, in which case it's totally okay. I'm going to go ahead and select Import. Once you've installed the package, you'll get this final notice to select and be able to choose anything that you may not want to import, but with this we're going to go ahead and import everything. All right, we're all set up. Now the first thing we're going to talk about is importing a character into Unity, and the way that we highly suggest is using the PSD importer. Now this should be a package that is already installed, and we'll go ahead and just double check that. And in project, we will find that we do have the 2D PSD importer. This will import all of the characters' layers as sprites and place them exactly as they were painted in the app. If you're using the 2D project template in Unity, the importer should already be installed. If not, install it using the package manager here. The exporting process simply requires files to be saved as PSB format. This is a format similar to Photoshop's PSD, but PSB allows for a larger file size. If you are using Photoshop, select this format in the Save dialog box. If you're using another app, just export the project as a PSD file, change the file name extension to PSB before importing into Unity. Importing into Unity is the same as with other assets. Just save the file into the Assets folder, or drag it right into the project window. So what I'm going to do is, instead of looking at a blank area of space here, I'm going to go ahead and open up one of the scenes. And so I will look at a gameplay scene, and I will open up Dragon Battle. And as for the character, we're going to look at the PSB model characters that have been imported. So in this case, we're going to find the knight. All right, if you want to open up your art folder, expand that out, you'll find characters. And here you'll find prefabs, which has all of our characters prefabs. But then if you go lower, you'll find some of the base characters as well. So we'll go into knight here. And this looks like where the PSB of the knight was imported. Now, if you expand that down, you'll notice each and every component that comes with that knight. You can see it's all broken down to individual pieces. Okay, now in the ebook, it recommends that there are key options to set. The first is import hidden. So right here. This option imports all layers from a PSB file, including hidden layers. Okay. The next one is mosaic. This setting is only available if the texture type is set to multiple. It makes sprites from imported layers and puts them onto a texture atlas. Leave this option enabled if you want to rig a character. So we will be rigging the character, or show how the character is rigged rather, in a moment. So this is important to be checked. Character rig, this option generates a character prefab with the same layers hierarchy and position as in a PSB file. This must be on. And then finally, use layer grouping. This adds layer grouping from the PSB file. Turn it on to group parts of a character, such as sprite swapped parts. After setting all the options, you want to hit apply, and this will finalize the character prefab, which can now be dragged into a scene. For this project, again, this is already, we're going to be kind of working backwards and really just analyzing what's already in this project. This PSB file has clearly been made into a prefab already. The next part is on building a character. To start rigging a character, we want to click the Sprite Editor button in the inspector to access the sprite import settings. So from the PSB character knight, we're going to go into the inspector, and we will find the Sprite Editor. So once we're here, we want to go to the Sprite Editor and select Skinning Editor. In this window, you can create and edit bones, create and edit sprite geometry, edit bone influence on sprites, and then create categories and labels for use in skins and sprite swap. Creating the skeleton. Start by making the character skeleton. Choose the Create Bone button and left click on the main window area. The first click will create a bone center, and the second click will mark the bone tip location. This tool chains and nests bones inside one another. If you want to change the bone placement, press the right mouse button and left click where you want the new bone to be located. To control which existing bone will be parent of the bones to be created, select the existing bone with the left mouse button, then create a new bone. Use the Edit Bone button to refine bones. The Split Bone button allows you to split bones into two. This is a good option for making limbs. If you make one leg bone and click where the knee should be, the bone will then split into a thigh and calf. You can also reparent and rename the bones in the Bone List view. To open this view, click the Visibility button at the top right of the bar. Then select Bone tab. To change the bone's parent, simply drag it in the list view. You can rename bones by clicking on an active bone's name. Giving bones a name will help you find them later. To verify that your hierarchy is correct, you can go ahead and test some poses. And then to reset, just go to Reset Pose. Sprite Geometry. In order to assign sprites to bones, they'll need to have geometry created. Start by pressing the Auto Geometry button. A small pop-up window will open, allowing you to define how the geometry will be created. It's a good idea to set all the sliders to 0 to keep the geometry as simple as possible. Enable the weights option to bind bones to the sprites automatically. Clicking the Generate for All Visible button will create and set bone weights for all the sprites. To do this for an individual sprite, simply double-click on the sprite. This is useful for tweaking the geometry of certain sprites. To go beyond this generated geometry and have full control on a number of vertices and how the geometry bends, the mesh will need to be edited manually. Use the following tools. Create vertex. Create new vertices or points, or move or delete those points. Create edge. Create edges either between two existing points or by creating a new point using the left mouse button. The right mouse button deselects the currently selected point and lets you make an edge between other vertices. Split edge. Splits an edge by creating a vertex in the middle. Use as few vertices as possible. Fewer vertices will help you save on performance. Since each vertex position needs to be calculated based on the bone's rotation, fewer vertices also make for better looking mesh bending since it's easier to set weights for fewer points. Additionally, each target platform will have an ideal game vertex count, so it's always good to optimize geometry. Once the geometry is nice and clean for all your sprites, it's time to set up weights. Weights define bone influence on each vertex from 0 to 1, where 0 means that a bone has no influence over the vertex, and 1 means that the vertex will move like it's glued to the bone. Good weights on the mesh can allow for great looking bending. Setting weights incorrectly can break the game's illusion and distort your sprites. To start setting up weights, you need to define which bones will affect a certain sprite. Click the Bone Influence button and select a sprite. In the small pop-up window, you can set which bones influence the selected sprite. Set only the relevant bones that need to affect the sprite and remove the rest. So for example, I have the torso selected, the chest, right shoulder, abdomen, hip, root, pelvis, and left shoulder are all influences to this sprite. From here, set up weight by using the weight brush and weight slider. The weight brush quickly adds the influence of the selected bone to the vertices by painting on them with the mouse. The weight slider is more precise, allowing you to select one or more points, then determine the exact influence of each bone with the slider. The brush is useful for quick weight setting, and the slider is useful for fine-tuning the areas where bones bend, like elbows and knees. The next piece is on 2D inverse kinematics, which will be later called out as IK. Now the purpose for 2D inverse kinematics is to animate your character in a way that your body makes sense when it moves. So the rotation of your wrist to your forearm, to your elbow, to your shoulder, to make everything look like it's moving fluidly as opposed to everything individually and respectfully on its own. To begin, we'll first need to add an IK Manager 2D on the object at the top of the hierarchy. This component will be responsible for managing all the IK solvers on the character. So, in our project, let's go ahead and find our character. An easy way to do it is to click on him in the scene view if you don't know exactly where he is in the hierarchy, like I just did. And now we'll go up to the character Knight. And we can see that in this project, the IK Manager 2D already is installed and configured. So what we're going to do if we were doing this from scratch is we would go to Add Component and search for that. Add that right there. Now clicking the plus button will add a new solver. The solver will calculate bones rotation to match the target transform. There are 3 solvers available. Limb. This is the standard solver used for legs and arms, which can solve up to 2 bones and the effector. Chain, CCD, or cyclic coordinate descent. This solver gradually becomes more accurate the more times the algorithm is run and is suitable for a longer chain of bones. And then chain, FABRIK, forward and backward reaching inverse kinematics. Like chain CCD, this solution becomes more accurate the more times its algorithm is run. It adapts quickly if the bones are manipulated in real time to different positions. In humanoid characters, the limb solver is the best choice because it is the fastest and optimized for 2 bone limbs. Start by adding limb solver to IK Manager 2D's list, which will create a new game object that will include the limb solver 2D component. Rename this game object to something descriptive like leg R limb solver 2D, which is what we'll do. In order to work, the solver needs two game object transforms, the effector and the target. The effector is placed inside the last bone in a chain, for example, the tip bone of a finger, and from there it will try to reach the target's position. So first we have to create the effector. When creating an IK for a leg, there are two bones, the thigh and calf, or shin. Place the effector as a child of the calf bone by selecting it and creating a new empty game object. Rename the game object as leg effector and move the effector to the tip of the bone. Add the newly created effector to the effector field on the limb solver 2D and press the Create Target button. A target game object will be created inside of the limb solver object. Now clearly this project's already set up with leg effectors with 2D solvers, and so whatever I just did totally broke what's working here. So I'm going to remove my part of it just to demonstrate how it actually is supposed to work. And by grabbing the proper effector, you can see how now the 2D solver works together with the limbs and bones. So you would want to repeat this whole process of adding the IKs with the other limbs. IKs, again, inverse kinematics, can also be added to non-limb bones, for example on the head and neck, which allows a character to look around at things. Sprite swap and skins. Not everything can be animated by rotating a bone. Sometimes you need another facial expression or hand pose. In this case, you can exchange one sprite with another by using sprite swap. Start using sprite swap by assigning a category and a label to each of the character sprites. The fastest way to assign sprites is from the skinning editor. With the visibility menu open, you go to the sprite tab. Here you'll find a list of all the sprites. If you put the layers for swap into separate groups before exporting to PSB, they should be grouped now. This is important because group sprites will be added to the sprite resolver to allow sprite swapping. Select all the sprites and groups in the list and right-click on them. Next, select the following two options in order. Convert layer to category and convert group to category. These options will assign an appropriate category and label to each sprite automatically. Sprites that are meant to be swapped will be in one category based on group name, and then click the Apply button on top. A sprite library asset will be created inside the character prefab, containing all the categories and labels created so far. So if you go into your character and you look down into all the individual parts that make up the character, a good one to look at here for this example is the mouth. And from here we can find the sprite resolver and see the different forms of the mouth. Skins. Sprite library assets let you create skins for your character. A skin changes the look of the character while retaining its animations, which is a great time saver. One base character can have all the scripts, and any change will also be applied to other characters. The workflow for setting up skin support may go as follows. You finish the base character, you rig it, you set up the IKs and sprite library, you make a prefab from the character, you can animate the character at any point. You then go to the skinning editor of the base character and click Copy button on the toolbar. This will copy the bones and meshes with weights. Create a prefab variant of this character. This will be the new character with a new look. Import the PSB of the new character and open its skinning editor. So for this, I don't have a fresh PSB that's not already assigned to a character, so we'll just pretend that it's the skeleton. Now the skeleton already has everything already assigned to it, but for demonstration exercise sake, we'll go ahead and hit paste. One thing you want to do is make sure the bones and mesh options here are selected and paste those. Now after that, you would want to fix any geometries that didn't fit right to your new skin and make sure that your weights are correct. Go to the Sprite tab. And here we basically want to do the same exercise we did before. Select everything, right click, and then convert layer, and then convert group, and then hit the apply. And once you've done this, you can then go back to the prefab variant that you've created you would go then to the sprite library and select your character that you just saved. And then to create new characters, you just follow all of those steps over and over again. Animation basics. To create your first animation, open an animation window by going to Window, Animation, Animation. Select your character. Clicking the Create button will create the first animation clip, and you can start by giving the clip a name. An animation clip is like a linear recording of how an object's position, rotation, scale, and other properties change over time. It also creates an animator controller, which takes charge of all animation clips and keeps track of which clip should be playing and when the animation should change or blend together. So let's go ahead and change up these preset recordings of animations a little bit. We can have a little fun. If we go to the Get Hit one, this one's pretty cool. It looks like the character gets knocked back a little bit. The feet sort of slide back, arms move. And what I'll do is I'll start the timeline at the beginning and look at frame by frame. And I'll start to move around some of these effectors so that maybe as she takes a step back, the arms move a little bit. I'll hit record and I'll move this one back a little more. I'll maybe like lift this leg up as if she's getting knocked off the ground. And in the next frame, you can see that since it's pre-recorded, the feet come back to where they were. So I'll just slowly move these up little by little. And then finally, I'll just let it snap back so that she comes back to the ground. And then let's see how that changed things. It's a quick animation, so it looks like her feet are only leaving the ground for a second. If we really wanted to, we could go back in here. And instead of them coming back so early, we keep going for a few more frames. That's pretty cool. All right, that's a little more fluid. So you can see you can experiment with this, and I only mess with the legs really, but you can have a lot of freedom to do very nice animations with this tool. Animating sprite swap facial expressions. Animating sprite swap works similarly, but it requires one additional step when setting keyframes. Set the new keyframes by choosing a sprite in the sprite resolver component. By default, the values between keyframes are interpolated, meaning that if you want to change from the first sprite in the list to the last one at a later frame, all the sprites in between would be shown. Sprite Resolver uses integer numbers to define the index of each sprite, so the interpolation in this case is not desired. To avoid that, select all the keyframes containing Sprite Resolver values. Right-click and select both tangents constant. Now the animation timeline will hold the values after keyframes instead of interpolating them, and the sprite swap animation should play correctly. So I believe what the ebook is saying here is that rather than automatically cycling through the various types of your sprites here, say for example this mouth, in the Sprite Resolver, in the animation section you can go and select all of the frames that the Sprite Resolver is in. So we'll go from beginning to end. We'll right click and we'll select both tangents and constant, which is already set for this project. And so in this case, the developer only has two types of the mouths showing up. It doesn't have the one with the teeth here. You see this cycling back and forth between these two. I'm not entirely certain on this one just because I wasn't able to actually get it myself to play all three. Finally, there's some optimization tips in the ebook, and I'll go ahead and read them off for you all. The first is to install Burst Package to improve 2D animation performance. When making a skeleton, avoid using more bones and sprites than you need. Simplify skeleton meshes by using as few vertices as possible. Turn on culling in the animators. This option will be turned off when the animated character is off screen to save performance. And avoid using skeletal animations for objects or characters that are small or come in large numbers, such as background birds, flies, or small animals. Instead, use different techniques like frame-by-frame animation or shaders. That's it for part 1. Thanks again for watching. I hope you enjoyed the content. Please leave me your feedback in the comments for how I can improve or what else you'd like to see in the future. Stay tuned, make sure you subscribe and click the notification bell so that you get notified whenever I release parts 2, 3, and 4. Take care, and I'll see you in the next one.